Okay, so jangan tekan Jangan tekan button record. Saya dah record. Nanti saya share. I will share the recording later in the Ulearn and also in the YouTube. Okay. Okay. So the third formula is P equals to V squared over R, and the last formula is P equals to V squared G. G is the conductance. Okay. So you can use either formula, either one. So for example, you have this circuit, you have voltage V equals to 30 volt, you have the resistor equals to 5 kilo ohm. The question asks you to calculate for the current I, conductance, and also the power. So can you try to calculate this value? So very simple example. The first one here, current, you can use the Ohm's law. V equals to I, R. I equals to V over R. V is the voltage 30, R is 5 kilo ohm. Okay, so 30 divided by 5 kilo ohm is 6 milli. 6 milli. Don't forget the unit. Okay, the unit for current is ampere. Okay, so this is for question 1. Next one is the question 2. Calculate for the conductance, G. So G is equals to 1 over R. 1 divided by R, R is 5 kilo ohm. So 1 divided by 5 kilo ohm, you will get 0.2 milli. The unit for conductance is Siemens, S. Okay, so it is 0.2 millisecond. The third one is power. So remember you have 4 formula for the power, so you can use either one. So over here I want to use P equals to VI. So V is 30, I is, you already calculate the I, 6 milli. So you will get 180 milli. Okay, the unit for power is watts, W. Okay, you can also try and do calculate for the power using the other formula. For example, I squared R. Okay, you will get the same answer. Okay, 180 milliwatts. Okay, so this is a very simple circuit analysis. Okay, but basically in your test, in your final, the circuit is not as simple as this lah. Okay, so this one for the power, you look at here, the power. So if you use a different formula, P equals to VI, P equals to I squared R, P equals to V squared over G, you still can get the same answer, which is 180 milliwatts. Okay. So next we have another example. Okay, we have another example. This one given the current source. Okay, we have the current source here. I equals to 2 milli and R is equals to 10 kilo ohm. Calculate for the voltage. The voltage is here. Voltage across the resistor. Calculate for the conductance. Calculate for the power. So basically the final answer already given here. Okay. So now let's try and calculate for this one. So the first one, voltage. We know that voltage is equals to I multiplied by R. I is 2 milli, R is 10K. So 2 milli multiply with 10K is 20. Okay, the unit is volt. Okay, the unit is volt, 20 volt. Okay, so next let's calculate for the conductance G. Number 2, G is equals to 1 over R. 1 divided by R is 10K. 1 divided by 10K, you will get 100 micro. The unit is as Siemens. Okay, and the last one, power, P. I want to use P equals to VI. V is, we already calculated the V, which is 20. I is the 2 milli. Okay, 20 multiplied with 2 milli, you will get 40 milliwatts. Okay, so very simple calculation. But you need to make sure that you remember the formula lah for the power, for the Ohm's law. That is very basic formula. Okay, so next subchapter is power and energy. Okay, stated here, power is the time rate of expending or absorbing energy, and power is measured in watts. Okay, previously we already know that P is equals to VI. Okay, and P also is the same as the division of dW over dt. Okay, so dW over dt is basically dW over dQ multiplied with dQ dt. Okay, so power is equals to VI. Okay, so this one is very important. This is your learning outcomes number 1 for chapter 2. It's stated here, if the current enters through positive terminal of an element, okay, the P will be positive and we call it as the absorbing power. Okay, so you look at here, this is the current. The current enters through the positive terminal. So this is positive terminal. The current enters through the positive terminal. So we call this as absorbing power. Okay. Passive element, remember what is passive element, what is active element? We already discussed in last week lecture. So passive element is the elements that cannot generate its own power. Example, we have resistor, we have inductor, we have capacitor. So all of these passive elements will absorb power. Okay. The second one, if the current enters through the negative terminal of an element, the power is negative and it is called the supplying power. Okay, so you look at here, this figure, this is the current. So basically, actually the current here is actually enters through the element. This is the element. Okay, it could be a resistor. No, this could be a source. So the current flows like this. Okay, so the current actually enters through the negative. This is negative. So the current enters through the negative terminal of an element. So we call this as the supplying power. Okay. Active element. Active elements is an element that can generate at its own source, its own power. Okay, such as current source, such as voltage source. Okay, so these active elements will supply power. Okay, so this is the difference between absorbing power and supplying power. Okay. Look at this example. So we have 4 connection. Okay, so the first one here, A, is it absorbing power or is supplying power?
Absorbing.
Absorbing power. Why it is an absorbing power?
The current flow through positive terminal.
Yeah, the current flows through the positive terminal. Okay, so this is absorbing. If you look at here, this one, the current, this one is absorbing or supplying. So if you look at here, this one, the
Absorbing.
current flows through the positive
Positive
terminal.
terminal.
So this is also absorbing. For C, the current flows through the negative terminal. So this is supply.
Supplying.
And this one, the current flows through the negative terminal. So this is a supply. Okay. Okay. So if you calculate for the power, for the observing power, you must make sure this is using the formula P equals to VI. V multiplied with I. The V is 4 volt. Okay. So if it's absorbing power, you must make sure that the current here is positive. Okay. But if it's applying power, you must make sure that the current here is negative. So your power will be negative. Okay. Next, we have what we call as the law of conservation of energy. Okay, the law of conservation energy stated that the sum of power in a circuit at any instant of time must be zero. Okay, sum of power. So stated over here, power supplied to the circuit must be balanced to the total power absorbed. So basically, power supplied in a circuit must be equals to power absorbed. Then only you can get sum of power equals to 0. Okay, because for power absorbed it is positive, for power supplied is negative. Okay. Next, the energy absorbed or supplied by an element from time t to time t is represented as this one. Okay, this is energy. Okay, energy. So it uses symbol W. This is energy. So energy is basically the power, the integration of power from time 0 to time t. Okay. You also know that power is equals to VI. So you can also use this equation is similar same as this one. So energy is basically VI, integration of VI with respect to t from time t0 to t. Okay. So the capacity to do work is measured in joules, unit J. Next we have exercise. Okay, the question said that compute the power for each element shown in figure Q1. For each element, state whether energy is being absorbed or supplied by it. Given the magnitude of VA and IA are 30 volt and 2 ampere respectively. Okay, so over here, given VA is 30 volt, IA is 2 ampere. This is also the same. Current is 2 ampere. Voltage VA is 30 volt. The question asks you to state whether it is absorbed or is supplied and then calculate for the power. Okay, so for this one, supply or absorb?
Supply.
Supply. Okay, so the current flows to the negative terminal. Okay, so this is supply. This one, the current flows to the positive terminal, so this is absorb. Okay. Now you want to calculate the power. So power is VI. The V is 30 volt. The power
-2.
supplied, so it is -2. Correct. Okay, so 30 multiplied with -2, you will get -60 watt.
-6.
Okay. This one P equals to VI. V is 30, I is 2. So you get 60 watt. Okay. Next, we have another exercise. Okay. So please ignore this. Please ignore this one. The question said that state the law of conservation of energy. Remember what is law of conservation energy? It stated that sum of P is equals to 0. So for figure Q.2, prove the law of conservation of energy using the calculation. Okay. So we must make sure that P supply equals to P absorb. Okay, then only you can get sum of P equals to 0. Okay, so remember, okay, so resistor, active or passive element?
Passive.
Passive. Passive element absorb or supply? Absorb or supply power? Passive element absorb power or supply power? Anyone can answer?
Absorb.
Absorb. Okay, so both of these resistor is, you can directly know that this resistor absorb power. This one, the voltage source is active element. So you can directly know that this voltage source is basically supplying the power. So basically the power of the source here must be the same as the power absorbed by both of these resistor. So now you need to prove by calculation. Okay, so first we want to calculate for the total power of this voltage source over here. So first we need to calculate the R total. So R total, this is a series circuit. So R total, RT is basically 100 plus 150. So you will get 250 ohm. Okay. So if you use Ohm's law, V equals to IR, you can calculate for the I. Okay, so you already have the voltage, you have the resistor. Now you can calculate for the I. So I is V over R. V is 5. R total is 250. So 5 divided by 250 is 20 milliamp. Okay, so now you have the power and you have the voltage, you have the current. Now you can calculate for the power. Power is VI. V is 5, I is 20 milli. So you will get 100 milliwatts. Okay. Now let's calculate the power absorbed by this resistor, by each resistor. So for example, I name this as R1, this is R2. Okay, so now I want to calculate for P1. P1 is I squared, I use this formula I squared R. I squared is the current, so the current since it's a series circuit, so the current that flows in the circuit is fixed, 20 milliamp. So you already calculate 20 milliamp, 20 milli squared multiply with 100. So you will get 40 milliwatt. Next, let's calculate for P2. Power at the resistor 2. So I squared R 20 milli squared multiply with 150. So you will get 60 milliwatt. Okay. So if you look at here, the P supply is 100 milliwatt, is the same as P absorb. P absorb is 40 milli plus 60 milli. Okay, so it's the same, 100 milliwatt, 100 milliwatt. It supply 100 milliwatt. The power absorbed is 100 milliwatt. Okay, so any questions? So actually we already finished for part 1, but I want to continue with part 2. Okay, but before we continue with part 2, we will take a short break. Okay, 5-minute breaks. Okay, so now is 10:57, then we will continue at 11, 2 minutes. Okay, so in the meantime, if you have any question, you can ask questions. So basically, so because I want to finish part 2 today, so tomorrow we don't have class. Okay, so take a 5-minute break. Okay, so it's already 10, so it is already 11, 3 minutes. So, so we can continue with chapter 2, part 2. Okay, so chapter 2, part 2, I've also already uploaded the slide. Okay, in the Ulearn for week 2. Okay, in week 2. Okay, so subchapter 2.4 is resistor. I'm sure you guys know what is resistor. Okay, perintang. So resistor is the simplest circuit element. Okay, so we know that based on the Ohm's law. Okay, this is the Ohm's law. Remember the Ohm's law, V equals to IR. Okay, so you can calculate for the R. Okay, R is basically V over I. Okay, so resistor is an element denotes its ability to resist the flow of current, and it is measured in ohms. Okay, so the function is to resist the current in a circuit. Okay, the unit is ohms, like this. Okay, so I'm sure that you guys already know this. You can determine the value of the resistor by using the color codes. So this is the resistor. Basically on the body of the resistor you have several colored bands. Okay, like this. So the first colored bands represent the first number, second colored band represent the second number, third colored band represent the number of zeros. Okay, and the last one here, okay, you see there's a gap here. So the last one here represent the tolerance band. Okay. So now, how can we actually know the value of the resistor based on these colored bands? You need to remember the value for each color. Okay, so if you refer to this table, the color for black, it is 0, brown is 1, red is 2, and so on. So basically you have 10 colors in total for the color band. Okay, so over here the slide already give you a hint to remember this color, the value for this color codes. Okay, so in English you can use this one: better be right or your great big venture goes wrong. Okay, but if you can remember the value, then you don't need to use this. Okay, this one is the tolerance band. Okay, for the tolerance band we have two colors. The first one is gold, second one is silver, this one no color, no band. Okay, so if it's gold, the tolerance is plus minus 5%. If it's silver, the tolerance is 10, plus minus 10%. If there is no band, okay, no color at all, then the tolerance is 20%, plus minus 20%. Okay, so now let's try, belum lagi. Okay, so this one is also the same table, but this one is in Malay. Okay, so for Malaysian students, so if you want to remember this color code, you can use this petua. Okay, and the final three, this is the tolerance. Okay, the tolerance band. So now let's try and calculate for the value of the resistor. Okay, so for example, you have this resistor. So this is the first band, second band, third band. This is the tolerance band. So the first band here is brown. Okay, assume it as brown. So brown, if you refer to the previous table, brown is 1. Okay, so the value is 1. Second number, this is black. So black is equals to 0. Okay. The third number represent number of zeros. Okay, so the third number here is green. So refer to the table green. So green is 5. So you need to add 5 zeros. Okay, you need to add 5 zeros. 1, 2, 3, 4, 5. And the last one is the tolerance band. The tolerance band is silver. Okay, go back to the table. Silver is plus minus 10%. Okay, so basically the value of the resistance is, just write this 1, 0, 0, 0, 0, 0, 0. Okay, so this is actually 1 mega ohm. Okay, this is 1 mega ohm with a plus minus 10% tolerance. So if you have a plus minus 10% tolerance, you must calculate 10% multiply with 1 mega, you will get 100k ohm. So basically, the actual resistance value is R 1 mega plus 100k, you will get 1.1 mega ohm. Okay, and another one, you have 1 mega minus 100k, so you will get 900 kilo ohm. So basically, the actual value of the resistance is between 900k until 1.1 mega ohm, because it has a 10% plus minus 10% tolerance, which is equals to 100 kilo ohm. Okay. Another example. Okay, so this is the resistor. The first band here is brown. So brown is 1. Green is 5. Yellow is 4. So you need to add 4 zeros. Okay. So this is actually equals to 150 kilo ohm. The tolerance band here is gold. So gold is plus minus 5%. Okay, plus minus 1, the R is 150 kilo ohm plus minus 5%. Okay, then you can calculate 5% from 150k, how much? So basically, the actual value of the resistance is between 142.5 kilo ohm until 157.5 kilo ohm, because it has a tolerance value of plus minus 5%. Okay. And the last example, this one. So we have orange. The first band is orange. So orange is 3. Second band is orange. The third band is red. So red is 2. So add 2 zeros. Okay, so this is basically 3.3 kilo ohm. Okay, you have a tolerance band. Go. It is 5 plus minus 5%. So please calculate 5% from 3.3k, how much? So basically you will get the actual resistance between 3135 ohm until 3465 ohm due to the 5% tolerance, plus minus. Okay. So this is the resistor. Now let's look into capacitor. Okay. unlike a resistor, so resistor dissipate energy, but a capacitor, it can store energy, which can be retrieved at later time, which can be used at later time. Okay, but still resistor and capacitor are both passive elements. It cannot generate its own power. Okay, this capacity, because it can store energy, we also call it as storage elements. Okay, and this energy is stored in its electric field. So the unit for capacitor is farad. Okay, F, farad. So capacitor is C. The symbol of capacitor is like this. Okay. So this is an example of real capacitor. Okay. Sometimes you already been given the value here. Okay. So how this capacitor actually works? So in the previous slide, I already told you that capacitor can store energy. Okay, how this capacitor store energy and how can it later be used to apa? For example, to turn on the lamp, even though the circuit already, the switch is already open, the switch is already turned off. Okay. So first, let's look at the first figure here. So you have a circuit with a battery. Battery is the source. You have a switch. You have a resistor. You have a capacitor. Okay. So take note, okay, the capacitor has a very low resistance load when the circuit is initially on. Okay, so basically the resistor here has a very low resistance, okay, when the circuit is initially turned on. Okay, you must know that in electrical circuit, current will always flow through a path with least resistance. Okay, current will always flow through the path that has a resistance yang lebih rendah. Okay, so if the resistance in the capacitor is low, so when you turn on the switch, okay, when you turn on the switch, now the switch is closed. Now the current can flow. So you look at the current flow here. Instead, it flows through the resistor. Most of the current flows through the capacitor because the capacitor has a low resistance. Okay. So when the current flows to the capacitor will charge. Okay, the capacitor will charge, and as the resistance of the capacitor climbs, the electricity begins to flow not only to the capacitor but through the resistor as well. So when the capacitor here is fully charged, okay, the resistance of the capacitor will become high. Okay. So when the resistance of the capacitor become high, now the current, you look at here, the current now also flows to the resistor. Okay. So once the capacitor voltage equals that of the battery, meaning it is fully charged. Okay. And it will not allow any current to pass through it. So when the capacitor is fully charged, the resistance of the capacitor is very, very high. Now, instead of flowing through the capacitor, now the current tends to flow through the resistor. Okay. Now the switch is still turned on. Okay, but remember the capacitor already stored the energy. Okay, it is fully charged. So what happens if the switch is now open. Okay, we turn off the switch. So now the current cannot flow. However, the lamp can still be turned on because remember the capacitor already stored the energy. Okay. As time goes on, the capacitor charge begins to drop, so does its voltage, then only the lamp here will turn off. Okay, so once the capacitor is fully discharged, no current will flow. Okay, understand the concept of capacitor. So to determine the value of a capacitor, similar to resistor, okay, you have something like this. For example, this is your capacitor. The value shown here is 474 M. Okay, 200. 200 here is basically the maximum voltage. Okay, so you have the first digit is the value, second digit is the value, third digit is the multiplier, and the last one is the tolerance. Okay, so if you have 474 M, the first digit is 4, second digit is 7, and you have a multiplier 4. So you need to multiply with 10,000, okay, 4 zeros, picofarad. So you will get 0.47 microfarad. Okay, so for the tolerance, okay, given this, the tolerance is M, so M is plus minus 20%. Okay, same as this example, you have 223J. 2 is the first digit, 2 is the second digit, 3 is the multiplier. Multiply with 10 to the power of 3 pico, you'll get 22 nanofarad. J is 5%, so you have tolerance of plus minus 5%. This one, 151K, 1 is the first digit, 5 is the second digit, 1 is the multiplier, so you multiply with 10 to the power of 1 pico, you will get 150 picofarad. K is plus minus 10%. Okay, so next let's look at the inductor. So inductor is another example of passive element. Okay, it can store energy in its magnetic field. So inductor actually consists of a coil of conducting wire. So basically, this is the symbol of conductor. This is the symbol for conductor. You look at here, the symbol is looks like a coil. Okay, the symbol looks like coil because the inductor is basically a coil of conducting wire. So if you have this one, okay, and you have a coil, you look at here, all of this is a coil of conducting wire. So this is example of inductor. Okay, and the unit for inductor is henries. We use H. H is henries. Okay, so next, over here is stated that what you see here is a battery. You have a battery. You have a light bulb. You have a coil of wire, which is the inductor. You have a switch. Okay. So based on the previous circuit, I will draw the circuit again. So you have a battery. You have a battery here. You have a lamp. And you have a switch. Okay. So without inductor, so this one is without inductor, what you would have is a normal flashlight. Okay, meaning if you right now the switch is turned off, no current will flow, the light will turn off. But if the switch is turned on, okay, if the switch is turned on, the current will flow and the lamp will turn on. Okay, but if there is an inductor, so this is an inductor. If there is an inductor, when the switch is closed, okay, the bulb burns brightly. The bulbs will turn on, but then it will get dimmer. And then when the switch is open, the bulbs still will burns very brightly, but then it quickly goes out. So the reason for this behavior is the inductor. So when the current first start flowing to the coil wants to build up magnetic field. So when the current flows through a coil, okay, so this is a basic concept. When the current flows through a coil, it will generate magnetic field. Okay, when current flows through a coil, it will generate a magnetic field. So while the field is building, the core prevents the flow of current, and once the field is built, the current can flow normally through the coil. So that is basically the concept of an inductor. And okay, so this is the value to determine the value of an inductor. So basically we have two inductor color code. The first one is 4-band code. This one is military code. Military code is used for military application. Okay, to differentiate between a 4-band code and the military code is that the military code has another band here with the color silver. So this is the military identifier. So if you have an inductor with a silver band like this over here, so this is the military inductor. Okay, used in military application. So this one, if you have a 4-band color code, okay, the first band will represent the first value, second band will represent the second value, third band will represent the multiplier, and finally the fourth band represent the tolerance. So similar, not exactly the same, but similar to the resistor and also the capacitor. Okay, so if you look at here, this is red, so red is 2, violet is 7, this is brown, yeah, brown, so this is brown, so you need to add multiplier 10. Okay, and the tolerance here is yellow, so look at yellow, no, the tolerance here is gold, so the gold is plus minus 5%. Okay, so any question? No question. If no questions, then we will proceed with the last subchapter for today, which is nodes, branches, and loops. Okay. So what is the difference between nodes, branches, and loops? So in a circuit, you will always have these nodes, branches, and also loops. So a branch represents a single element, such as a voltage source or resistor. So if you have wires and you with a single with element like this, only one element, you have one resistor, then we call this as a branch. Okay, a node is the point of connection between two or more branch. So you look at here, over here you have 3 branches, the first branch, second branch, the third branch. Okay, this is the point of connection. So the point of connection of the three branches we call as nodes. And the last one is the loop. So loop is any closed path in a circuit. So this is the circuit and this is the closed path. Okay. So this is the loop. Okay. So stated over here, independent loop is a loop that contains at least one branch, which is not part of any other independent loop. Okay. And it also stated that a network with B branches, N number of nodes, and L number of independent loops will satisfy the fundamental theorem of network topology. So basically, it's stated here, branches equals number of branches is equals to number of independent loop plus number of nodes minus 1. Okay. So now let's look at example. So this example, you are given the circuit like this. The question asks you how many branches, how many nodes, how many loops, and how many independent loops are there. Okay, so take note, if you have a circuit like this, in order to determine this or in order to do analysis, you must first simplify the circuit. Okay, so if you don't simplify the circuit, you may tend to get the wrong answer. Okay, you may get confused and you may get the wrong answer. So remember, if you have a circuit like this, make sure that you simplify it to the most simplified one. Okay, so this one basically we have three nodes. Okay, so this is the first node. I call it as node A. Okay, it connects this branch and also this branch. This is another node. I call it as node B, and this is another node. I call it as node C. Okay, so if you simplify this circuit, you can actually redraw the circuit. Okay, so first we start with the A. So A is connected to 5 ohm, connected to B. And then we have A connected to the supply, connected to C. Okay, A connected to the supply, connected to C. This one we have B connected to 2 ohm, connected to C. This one is we have B connected to 3 ohm, connected to C. And last one we have the B connected to 2 ampere source, connected to C. Okay, so this is the simplified circuit or the equivalent circuit. So from this circuit, then only you can, it is easier for you to determine how many nodes, how many branches, how many loops. Okay, so if you look at here, for the nodes, we have three nodes, A, B, C. Okay, we have three nodes. Branches is this one. Okay, so branches we have 1, 2, 3, 4, and 5. Okay, loops, how many loops? We have 1, 2, 3. Okay, so we have 3 loops. Okay, any question? We have how many independent loops? Can anyone answer? We have how many independent loops? Berapa?
Dua.
Dua.
Good.
Satu.
Ada dua, ada satu. So let's go back to the
Dua.
definition.
Tiga.
Definition of independent loop, okay, is a loop that contains at least one branch which is not part of any other independent loop. Okay, at least one branch which is not part of any other independent loop. So berapa? At least one branch that is not part of any other independent loop. Dua. Okay, two. 1 and 2. At least one branch that is not part of other independent loop. Okay. So next is the rules stated here. The first rule.
Madam.
Uh-huh.
So tadi berapa dia punya independent loop?
2.
2 eh?
Kenapa?
Tak ada apa-apa. Okay.
So the rules, we have two rules that you need to know. It stated that the first one, two or more elements are in series and carry the same current if they exclusively share a single node. Okay, so if you have two or more elements, okay, over here you have two resistors connected in series and carry the same current if they exclusively share a single node. Okay, so basically I1 that flows through R1 is the same as I2, which is the current flows through R2. Okay, so I1 is equals to I2. This one, if you have two or more elements, okay, you have three resistors here connected in parallel and have the same voltage. It will have the same voltage if they are connected to the same two nodes. Okay, so basically, if you have elements connected in parallel like this, okay, the voltage V1 is the same as the voltage V2 is the same as voltage V3. Okay, you must always remember this rules. Okay, so if you have a parallel connection, V1, the voltage here is always the same as the voltage here and also the same as the voltage here. Okay. So we have finished chapter 1 part 2. Any question? So next week we will cover on Kirchhoff voltage law and also Kirchhoff current law. So this one is very important for chapter 2. So this is more on the calculation part, Kirchhoff voltage law and also Kirchhoff current law, KVL and also KCL. So any question for chapter 2 part 1 and chapter 2 part 2? Okay, no question? Semua faham? Faham, okay, bagus. Okay, so remember. Okay, so remember to do a short summary in the ULearn and also leave some feedback or comments in the ULearn because I will take that also as the attendance. Okay. Remember to submit your tutorial next week on Friday. Okay.
Next week kan bukan this week.
Apa?
Next week kan bukan this week.
Next week. Next week Friday. Tutorial 1.
Okay.
Okay, so this week we don't have tutorial because we haven't finished chapter 2. Okay, so if we don't have any question, then we can finish our class for today. Okay, thank you.
Okay, thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.